Good morning, everyone. We're going to be talking about translations with vectors today. Our essential question, how do we translate figures using vectors? Our learning goals, I can draw the image of a translation given a pre-image and the description of the transformation. Also, I can explain why a transformation or sequence of transformations is rigid or non-rigid. So we saw the rigid and non-rigid discussion in our last lesson, and so we're going to continue that on, and today we're going to be focusing on translations. Also, for the notes today, I would strongly encourage you to print the Google Doc if you can. If you can't, then I would probably choose taking notes in the Google Doc rather than writing your own copy, but it is up to you. So first preferred is to print, next would be using the Google Doc. Also, you probably will need colors today. All right, so translations with vector. So a translation is a transformation that slides all points of a figure the same distance in the same direction. So it's basically a translation is just going to move your figure. Then a vector, which is how we're going to do this, is a quantity that has both magnitude and direction. If you've seen the movie Despicable Me, the villain in the first one, his villain name is Vector, and he says both direction and magnitude. Anyways, so there you go, magnitude and direction. All right, so a vector has an initial point, which I'm going to point out here. The initial point is where we start. It's this one right here. And the terminal point is where we end. And so a vector always goes from the start to the end. And it always follows the direction of the arrow. So it looks a little weird because it is like a segment where it has endpoints, sort of, but it has direction. So there's always an arrow that tells us which way to travel. Okay. And then we have vectors on the side here. Vectors can be named in two ways. So I can call this vector by the letters, the endpoints, if you will. I can say EF, and then a vector symbol is like a half arrow, like that. So this is vector EF. When I write a vector, it always has to go from the from the initial to the terminal. So always start at the beginning and end at the end. So I have to follow the direction of the vector, just like array, same kind of idea, except array goes forever. A vector stops. All right, the other way I could is if there's a letter here, like V for vector, then I could say this is vector V, and those will be a lowercase letter. Kind of like when we had lines and it was like line L, but it was a cursive L. Sorry, I'm just going to write that a little bit neater. So I can say or vector V, but notice that like half arrow for a vector. Okay. Then this has a note that is on page 65 in your textbook. If you want to check it out there, or even if you want to cut that out from your textbook and put it in your notes, if you're doing notes by hand, that might be an easier way to do it. All right, so we're going to draw the image of triangle ABC after a translation along vector V. So they give us vector V. I forgot my little vector symbol here. Ooh. Sorry, just seeing that reminded me. We want to make sure we're mathematically accurate here. So vector V, there we go. Fantastic. Okay, so how this works is we're going to take a look at our vector. We're going to see where we start and where we end. So even though a vector has an arrow, that's why it's important that you have that vector symbol, because it's telling you this is a vector, which means that arrow is direction, not saying it goes forever and ever. So we're going to start at the initial point and end at the terminal point, and we're going to count. How do I get from the initial to the terminal? Well, I go up 2, and I go over 1, 2, 3, 4. So that was up 2, and I'm going to be a little more specific in my over. I'm going to say right 4. So the vector, this is from vector V, this is what it's telling us to do. Go up 2 and right 4. So I'm going to take every single point in my triangle and go up 2 and right 4. So up 2, right, 1, 2, 3, 4. And this is going to be A prime. And I'm going to, I don't know if I said, yeah, I said every single point in the triangle. Okay, then we're going to do that with B. Up 2, right 4, 1, 2, 3, 4. There's B prime. And then up 2, right 1, 2, 3, 4. There is C prime, and I'm going to move my little 4 so it's out the way. Great. So this one is C prime. This was going over 4. All right, and then when I connect the dots, there is my new triangle. Don't mind my messy connecting, but hopefully you can see. If we look, take a look and compare the new triangle to the original, we should be able to make a decision about rigid or non-rigid. Did the triangle change size or shape? No, it didn't. As long as I draw my lines a bit straighter here. It didn't change size or shape. It's still the same size and shape. It just changed location. So this would be rigid motion. And there you have that. All right, so now we're going to look at drawing the image of ABCD after a translation along vector V. And so vector V is over here. Here's my initial and here's my terminal. And so I'm going to follow the directions of V. It looks like I go to get from the initial to terminal along the arrow. I'm going to end up going left 3 and up 1, 2, 3, 4, 5. Looks like I go up 5. So that was left 3 and up 5. So this is the direction of my vector V. Oopsie, the V got a little crazy there. So that's what I'm going to do to every single point in my figure is follow those directions. Move the points left 3, up 5. Up looks a little, write that one more time, sorry. Okay, up 5, there we go. All right, so I'm going to start with A, left 3, up 1, 2, 3, 4, 5. There's A prime. Then I'm going to go left 3, up 5. There's B prime. Left 3, up 1, 2, 3, 4, 5. C prime. And left 3, up 5. D prime. Then I would connect the dots, of course. And then as I'm connecting here, I want to compare this figure to the original. Did it change size or shape? No, it did not. So this would be rigid motion, which is one of our learning goals, not so much what the question asked, but something we want to be looking at each time. And that's it. All right, on to component form of vectors. So component form, we're going to talk about another way to write our vectors. So I can say this is vector PQ from P to Q, always following the direction of the vector from initial point to terminal point. So P to Q. And then I put my little vector symbol up here. There we go, vector PQ. But this is equivalent to writing it in component form. So component form is going to use these pokey parentheses. Let me write them a little bit better. So not a regular parenthesis, but it's kind of a pokey side here. And the numbers that we put inside, it's going to kind of be like an ordered pair. The first number is going to tell us left or right, based on whether it is positive or negative. And then the second number is going to tell us whether we go down or up. So left or right, and this one is going to be down or up. And again, that's based on negative or positive. So left would be the negative, not -1, sorry, I don't know where the 1 came from. Negative means I'm going left, and positive means I'm going right. Negative means I'm going down, and positive means I'm going up. Okay, so we're going to take that vector and we're going to look at how does the vector move? Well, it goes to the right 5. That's this number right here. So I'm going to put that in my first spot, then a comma. Then it goes up 3. I'm going to put that in my second spot for the up or down or up. And then that's it. That's my component form, just the pokey parentheses with the 2 numbers. I do want to comment the first number always represents the X direction, left or right, and the second number represents the Y direction, down or up. So it's a lot like an ordered pair. It is not an ordered pair, but it follows that same kind of pattern or convention. All right, let's go to example 2. Draw the pre-image and image of triangle ABC under the translation along vector -4, 1. Okay, so this is a vector because it has the pokey parentheses, -4 and 1. So this first number is telling us how to move either left or right on the coordinate plane. So because it's -4, this is telling us to go left 4. It's a left 4, right? And then the 1, since it's positive, is telling us to go up 1. So the vector in component form tells us how to move. And so instead of looking at a picture of it and counting ourselves, this one just tells us what to do. So I'm going to take every single one of those order pairs A, B, and C and move them left 4, up 1. Let's start by graphing them. So over 2, up 4. This is going to be A. Then over 1, up 2. This one's going to be B. And then over 4, up 2. This one is going to be C. So here is my original figure, ABC. And now I'm going to grab a different color to do my translation. And I'm moving every single point left 4, up 1. So I'm going to use blue. I'm going to go left 4, up 1. There's A prime. Left 4, up 1. There's B prime. Just a quick reminder, when we move or change the figure's location or do something to it, we use the primes to tell us this is a copy. So A prime is a copy of point A. B prime is a copy of point B. And then C prime is going to be left 4, up 1. C prime is a copy of C. Then I'm going to connect the dots. And when I do that, I double check my triangles. It looks like they did not change size or shape. So this again would be a rigid, I don't know why I have midget. That's funny. Let me try that one more time. Rigid motion. Just write whatever I want. Rigid motion. There we go. All right, last example. Identify the vector that maps. Get rid of that. That maps triangle ABC to A prime, B prime, C prime. So we're looking for how does it move? And we're going to write it in component form. So we're going to do every single point. We're going to double check it. I'm going to start with A. How does A get to A prime? So to get from A to A prime, I go up 1, 2, 3. And I go to the right 1, 2, 3, 4, 5. And I'm going to redraw that arrow because it's a little bit irritating. Here we go. It's a little better. Okay, so then I'm going to test the others quickly. I'm going to pick a blue. And so I'm going to now check for the other points to match up with that same motion. So from B, I would go up 3, 1, 2, 3, 1, 2, 3, and over 1, 2, 3, 4, 5. Yep, it works. That's a little check mark. And a little nicer. And then I'm going to change color again and try C. So C to C prime. Up 1, 2, 3, over 1, 2, 3, 4, 5. C prime. That one works as well. So that means, again, that I was going up 3, and then I said over 5, but I'm going to be more specific that it was right 5. All right, so this is what I'm going to use to write my vector. When I do write my vector, I'm going to use my pokey parentheses, and I'm going to make sure that the first number represents the x direction and the second number represents the y direction. So the x direction means left or right. My left or right number was 5, and it's positive because I'm going right. Then my y number, or my y direction, is going to be up or down, which was 3, and it's positive 3 because we went up. And that's it. That's the answer. The little pokey parentheses with the 5, 3. We are done. Nice job, guys. Have a great day.